Hello everyone, it's Benny, and welcome back! It's been a while, hasn't it? Today, I'd like to talk about why I haven't made videos in the past 3 years. I'd like to talk about what my plans are for the future, because as some of you have guessed, I don't intend to stop making videos. I've never really intended to stop making videos. I'll explain in a bit. I'd like to talk about a few cool things because of a lot of really exciting developments in games and technology have happened in the last few years, and oh my word, I would love to talk about some of it. I am so excited about that stuff. And of course I've done a few things. I'd like to talk about that. And yeah, I suppose that's just about it. So, come, join me, and let's talk just about what's going on. So, I'm going to start by getting the mystery of the Vanishing Benny off the table. So from about the start of 2015 to about mid-2017, roughly that 2.5-year period, a lot of things happened in my life, and it was pretty much just a continuous series of rolling disasters. And I mean disaster in the truest sense of the word here. There was death, there was destruction. There was even about a month-long period where I genuinely didn't know whether I was going to live or die. It was not a lot of fun. I'm glad that part of my life is over with. But thankfully, all's well that ends well. As of the start of 2018, everything in my life that was impacted by that appears to at least be back at an acceptable level. So that's good. And while all that was happening, I was continuing my education. I finished my bachelor's degree. I now have a bachelor's degree in computer science with honors and a minor in mathematics. And I'm currently working on my master's degree. And if all goes according to plan, I will be getting that this December, 1 semester early. Hooray! Yeah, so that's what's been going on with me. And between all that craziness, it wasn't practical to continue video making. And that's really the reason why I haven't been making videos. I had some other things that unfortunately forced themselves to take priority in my life. Because frankly, I'd much rather be making videos. That was a lot more fun. But anyways. So, now that we've got that out of the way, I can talk about the fun stuff. Yeah. So first of all, I have a little bit of a code gift for you guys. This is a really neat way of doing frustum culling that I have not found anywhere else on the internet for some reason. And I don't know why. I don't know why this technique is so obscure, because this is the technique that makes the most sense to me. But I don't know. So basically, if you've seen frustum culling anywhere on the internet before, it all says pretty much the same thing. You take your view matrix, you use these magic equations that someone did academic level research to derive to extract the view planes from them. And once you have the view planes that represent the view frustum, you can take a bounding volume and test it against one of the planes. If the bounding volume is entirely outside one of the planes, therefore it's outside the frustum, therefore you don't need to draw it, therefore frustum culling. That's sort of the general way they do it. And that's not a bad way to do it. I mean, it's logically correct. The problem with that is, why do you need to do this crazy, complicated nonsense of extracting view planes and testing against it? I never understood that. It never made sense to do it that way to me, because in my mind, logically, all the information about what the view frustum is and how that relates to your geometry space, well, that's exactly what the MVP matrix is. The MVP matrix takes your geometry and moves it into the view frustum space in order to, well, ultimately draw it. So in theory, you should be able to do frustum culling just by transforming the points with the MVP matrix. And that's exactly what this does. What this does is it transforms the AABB into basically clip space. And from there, you can test, okay, is this AABB still in the viewing area? If the AABB ends up outside the viewing area, therefore, it's not in the view frustum, therefore it won't be drawn, therefore you can cull it. And it's so much simpler because you don't have to do crazy equations, you don't have to develop a separate data structure for your view frustum. You literally just pass in the MVP matrix, transform the AABB, there you go. I don't get it. I don't understand why this method isn't more well known. I mean, I'm sure it's more well known in certain circles, but it's definitely not in an obvious location on the internet. But yeah, so I'm not really going to talk too in-depth about it. I just wanted to give you the general idea of what it is. And here it is. It's a really cool way of doing it. Oh, and there's something else I want to point out. This is actually a faster way of doing frustum culling than doing it the other way. Because with this, okay, let's check how many dot products this takes. So, transforming a vector with a matrix, that's 4 dot products, right? So, you have 4 dot products, you have 8 points, that's 32 dot products. And then you'll do a comparison for every point against every plane. There are 6 planes, 8 points, so 48 comparisons. 32 dot products and 48 comparisons. If you do it the other way, then you have to do an AABB plane intersection test for all 6 view planes. Doing an AABB plane intersection test requires you to take the dot product of all 8 points of the AABB. So it's 8 dot products times 6 planes, 48 dot products, and still the same number of comparisons, still 48 comparisons. So I don't get it. I don't understand why the other method is such a more widespread and preferred method. I don't know. Maybe there is some special advantage to having a separate view frustum data structure that I haven't stumbled across yet. But I don't know. I want to throw this out there because I found this really useful, and it's my preferred way of doing frustum culling now that I've figured out how to do it. So there you go. And I just realized I forgot to mention my plans for videos. That's probably something you all are interested in. So my plans for videos. It's definitely something I'm interested in. I'd love to do more videos. I've never really wanted to stop. There's so much I still talk about. I never even got the 3D engine in a place where I personally wanted it to be. Plus, I never got to make all the games I wanted to with it, which is really the whole point of the engine to begin with. And so many cool things have happened, like Vulkan, and oh my word, I have so many things I'd love to make videos about. But, alas, I cannot commit to a specific return time right now, but I'm definitely doing a few things that are pretty much going to lead into some videos some way or another. And I'd like to talk about a few of those. Just, I'd like to share what I'm up to. I figure some of you guys will be interested in that. So, first of all, something I've been experimenting with a lot lately is binary space partitioning trees. I know, it's a little bit of it's not the preferred way of doing 3D nowadays, but that's part of the reason why I want to explore it, because I feel like a lot of things that use it, they use it for a very specific technique, and I felt like there's different ways. I feel like there's some room to do it a little bit differently that actually might be really, really good. I felt like there's ways. I'll just show you what I have so far. So I went ahead and implemented a basic BSP tree-based thing. There's the tree it's building, and there you go. So here we go. This is a BSP-based renderer. And interestingly enough, this is using the 3D software renderer from that series. So I actually feel oddly like I'm making some weird part of Quake because I'm doing BSP trees and software rendering. But yeah. So here you go. It's just, and yeah, this mesh, it's designed to be sort of kind of like a level, but also have a lot of things that will be very weird for a renderer to handle. Like this, the one-sided polygon issue. And normals are weird on this, that's why the lighting's odd. Here, the texturing is a little bit weird, so this is just a flat color. And there's all sorts of just odd quirks in the geometry that'll cause interesting corner cases in rendering. And that's why I really like this. It's a good test mesh. But anyways, that's not what I'm here to ramble about. I'm here to ramble about something else. Right, the BSP trees. So, my idea, I actually had a couple ideas. The first of all was that perhaps it would be better to build a BSP tree. Like, usually, when you're building a BSP tree, right, you typically want to optimize it to minimize the number of cuts and to balance the tree, so that it's basically as even as possible. And there's a lot of heuristics for that, but they involve doing loads of partitions, test partitions, and it just that makes it take forever to get a good BSP tree. Plus, they're not even perfect heuristics anyways. So I was thinking, what if you used a genetic algorithm to build a BSP tree? So basically you'll build several random BSP trees, and you'll see how well the different partitions do overall. And whichever random partitions are doing the best, you sort of mix their sets of partitions. So these partitions are tending to work well. You sort of mix between them to get better versions of partitions, and slowly but surely close in on the optimal solution. It kind of works. It can build a BSP tree, and it does a good job, but it's not, at the end of the day, it's not that much better than what you'd get with the heuristics, and it doesn't perform that much better either, so that idea didn't work out too well. But I tried something else that I thought was kind of cool, and that was a dynamic BSP tree. Because most people think of, hey, BSP tree, you're slicing up meshes. Well, screw that. What if you're just using it to divide your scene space? So you pick a plane. Basically, you start out with just everything in a flat list. And once you get past a certain number of objects, say 16, sure, then you'll generate a plane that splits those objects in half. Roughly 8 of them on one side, roughly 8 on the other. Not exact, because partition isn't supposed to be... Well, creating an arbitrary plane to split an arbitrary dataset is not a trivial problem, and really you don't need a perfect split anyways. The whole point is just it's about even, right? So using some heuristics, generate a plane like that, and yeah, basically use it like a dynamic data structure. So then you have a little bit fewer on each side, and you can sort of slowly split, and you'll be able to quickly traverse the space. It basically has all the advantages of any other data space It basically has any of... I cannot speak today. It pretty much has all the advantages of all other partition the object lists like structures like that. there. So it's the same sort of thing as you get with an OCT tree or a KD tree, but essentially it's more general, and it has all the various advantages like convex space of BSP trees, and etc., etc. Problem is, it has all those advantages, but it doesn't really do it a whole lot better than any of the other ones, so... It was a cool experiment. BSP trees are a very, very useful data structure, and I still have a few cool ideas of things to do with them. Like, what if you do instead of partitioning an object entirely, if you have an object with a super, really high poly count, and it's really big, really spread out, lots of convex things, lots of potentially occluding things, then maybe just use a few binary space partitions just to get it into a little bit of a simpler form, so that you have all the different segments, and then you can do something like frustum or occlusion culling, or preferably both, and speed up the drawing of it, and maybe do some level of detail with the different leaves. So basically, as a way to simplify rendering of complex meshes, and allow some optimization that you wouldn't otherwise be able to take advantage of. That's a really interesting and useful way to use a BSP tree that I'm probably going to end up implementing at some point in my ultimate engine. But as far as just a general data structure, it's good. It's definitely not a terrible choice. It's just, I don't think for most applications the pros are better than the alternatives. But definitely look into it. If you're dealing with something that requires a 3D data structure, don't rule out the BSP tree. Give it a shot, see how well it applies to your problem, because it has a lot of cool stuff to it, and it's a really, really useful data structure. In fact, it's theoretically the optimal 3D data structure if you can build it and take advantage of it correctly. The problem, of course, is it's really hard to take advantage of, and you can't do it in a lot of cases to its full extent. But there you go. So, something that I want to show you, and you'll see why in just a second, is that same sort of test mesh, that same sort of scene, just in really a regular 3D engine. So no crazy BSP nonsense, no software renderer. It's using the graphics card and more traditional 3D organization, well, just more normal 3D engine systems. So yeah, here's what it's like. As you can see, there's per pixel lighting and linear filtering on the texture now, so it looks a little bit nicer. And as you can see, a lot of the issues and weirdness are still there, like this, because again, normals are weird on here. It's not an entirely closed mesh. It's like a Mobius mesh, because it doesn't entirely have an inside or an outside because of this odd polygon issue. And yeah, there's still the tunnel under here. There's still the weird texture oddness on here because, yeah, the texture coordinates are odd. And yeah, here, this is what it looks like. But what's interesting is what exactly is rendering this, because it's not something I've shown on my channel before. This is not the 3D game engine that I showed you. This is something new. And actually, I think you'll appreciate the story behind this. So, in January 2018, I decided that month I was going to devote all the time I had outside of everything else I deal with in life, all my free time that I wanted to work on something, I was going to try making an indie game with the Dare engine. And the goal was just see how far I get in a month, right? Reasonable goal. See what I can do. And so that's exactly what I did for January. All my extra time was spent just seeing how far I got making an indie game with the Dare engine. I got pretty far, I think. I was happy with my progress. I managed to get all the core mechanics implemented and working. I managed to get a decent chunk of the graphics done, not too much, but enough that you could definitely sort of see the direction the game was starting to go in. Managed to do a ridiculous amount of the soundtrack. Got I think something like 10 different pieces of music ready for that. I don't know how that happened, I'll be honest. But yeah, I made good progress on it, that's the whole point. And I realized, the Dare engine's actually a really, really nice framework for practical game development. I was actually kind of surprised just how well that held up. It was really nice to work with. So that gave me the idea, alright, what if I did 3D game engine, except with the Dare engine layout and architecture? And I took that sort of marriage idea, and that's sort of this is. I call it basically Dare engine 2.0. So yeah, it has all the fancy stuff the 3D engine has, just in that more elegant layout and architecture. And that's really nice. But the reason I'm mentioning this is because it's not just something I'm doing just to do it. My idea here, I ultimately want to do something kind of like a 3D game engine series Take Two. It's sort of both its own standalone series and a sequel to the original 3D game engine series. And I have a clear vision for the series. I'm still not entirely sure how to phrase it yet, but it's one of those things where it's a very solid, clearly defined idea in my mind, but I don't really know what words are the best to represent it. I'm sure you've had a problem like that before. I'm sure you can understand what I'm going through, but yeah, that's sort of where it is right now. And I guess I can sort of give it a shot. So, the general idea. So, here's my sort of overall vision. In the original 3D engine series, I essentially tried to do everything. I started with building the renderer, I added on features, I added on stuff like entities and transforms, and I sort of had a transform hierarchy going on. And yeah, basically I just started from nothing and slowly built in everything. Everything what was in the scope of that series. Anything and everything related to making a game engine or 3D what was in the scope of that series. This one's going to be I just try to narrow the focus a little bit. If it's really a heavy-duty, something really, okay, like shadow mapping, for instance, definitely not in the series, because that's really rendering focused. It's a cool thing to have, but I wouldn't show you how to do shadow mapping in the engine series, because really that's about rendering. It's not really about making a game engine, that's about how do I make a fancy renderer. So instead, what I would do is I'd have I already have a series about shadow mapping, I'd point you to that, and then if I wanted shadows in the game engine for some reason, I'm doing something else, and say, hey, we really need shadows for this. I'd say, okay, viewers, I already showed you how to do shadow mapping, now here's how you integrate that into the engine. We're not writing new code from scratch, we're integrating the feature in. And that's sort of how it's going to be. It's more of it's more focused on building a platform for game development as opposed to here's all the individual components of an engine, how do you do all of them? And that's really, I think, a really good way to put it. It's about how do I build a platform for creating a game? I want to focus on that aspect of it. And how do I make it practical? Because just using a straight-up 3D renderer and a straight-up 3D physics engine and a straight-up audio engine and all the other components and just slapping them all together doesn't necessarily make an efficient 3D engine. So how do you get all these things to play nicely together? So instead of how do I build an audio engine, here's a good example. Instead of how do I build a rendering engine and how do I build a physics engine, it's how do I take 3D renderer and 3D physics and get them to play nicely together in a neat, organized way that makes it really, really nice for actually building a game. That's sort of the vision I have for this new series idea. And the idea is eventually, once I have that, then I can start moving into tutorials on actually making games based with this. And that's really where I want to be, because there's a whole lot of stuff, really exciting stuff happening in the world of... There's a lot of really exciting stuff happening in the world of actual game creation right now. And I'd love just to show you guys some of the cool stuff that's going on there. But, if you want to make a game and not redo a billion things, you do need a decent engine, and you need it decently well organized. And there's still a lot of stuff that I really don't feel I've covered anywhere, and I've really wanted to, especially, like, spatial data structures. I've wanted to cover those forever, and I don't know how I've never gotten around to that, to be honest. It's always something that has been on my list of things to do that I've never quite done. Okay, technically I implemented a quad tree during the Dare Engine live streams, but, for the most part, I just haven't really covered it for some reason. That bothers me. I want to do that. I'll leave it at that for now. But, yeah. Before I get too far from the subject, though, I think it's just worth giving everyone a reminder that, as of now, this isn't really it's not like I'm announcing this is something I'm about to do. Again, I don't know when I'm going to be able to return to making videos like I'd like to. It's, I still have a lot of things going on. But hopefully, in the reasonably near future, I'd love to make some more videos. But anyways, even if I do, right now, that's not the official plan. That's just my general vision. It's a very general vision of how I'd like things to eventually go, somehow, some way. Maybe not exactly like that. Maybe I'll come up with a better way of doing it. And then you'll end up with something different. Same general direction, just maybe not in that specific manner, That's where I am right now. It's an idea. It may or may not go like that, precisely. Or, oh dear, hopefully this doesn't happen, but it's also possible that for some godforsaken reason, even more crazy disasters come up, and oh no, I would be so daggone annoyed if that happened at this point, because, oh no. Just, no. Actually, that reminds me of something I kind of wanted to share with you. So, one of the disasters was lightning. Lightning came in and destroyed a whole bunch of various things, including my old computer. So, sayonara to that, but one of the things that maybe not lost isn't the right word, because technically the hard drive survived, it's just really painful to get anything off of it, even if the data is there. But yeah, one of the things that's on there, you might remember that I've done a whole bunch of different stuff with real-time ray tracing over the years. I've just been trying various experiments, trying to see how well that would work out as an alternative to traditional rendering. I finally hit what I think is just the peak of those experiments with some file on that hard drive. And here's what it is. It's a real-time path tracer. It runs full screen, 60 frames per second, on, get this, a 10-year-old entry-level graphics card. Well, maybe not strictly 10 years old. I think it's from 2009. maybe 2010, but I think it's 2009. And yeah, granted, it doesn't have like this amazing ray count. I think it's like 4 to 8 rays per pixel, so definitely not amazing, but enough that you could reasonably do things. I got some decent looking color bleeding going on in there. And it was really cool. I thought that was awesome because it meant, hey, this is practical. You could make a rendering engine with this and expect it to run reasonably well on graphics cards that people are actually going to have, computer setups people actually have. You could put it in a marketable game. And so I was really, really excited when I got that working, but, it's ultimately, my conclusion on my whole ray tracing, path tracing experiments is it's cool that you can do all those effects, but ultimately, I don't see the crazy advantage over traditional rasterization techniques. It's still required a load of coding to do. It's not like the renderer magically got simpler. You still had to wrestle with the graphics card, and honestly, that's the hard part of writing a 3D renderer, in my opinion. Just getting through all the fluff you have to do to wrestle the graphics card into doing what you want it to. And you still had to do that, so, even if it's mathematically simpler, that's not the hard part. And sure, you could do some fancy effects, but you can also do fancy effects with a rasterizer. It's just you do it a little bit differently. So, overall, I think the whole idea of real-time ray tracing is more hype than practicality. I think for practical purposes, rasterizers are still really the way to go. Also, it's an enormous pain in the rear to deal with managing spatial data structures on a graphics card for ray tracing. Alright, somebody needs to get on that. Alright, it shouldn't be that difficult to get a decent spatial data structure working in graphics cards, but it is. But anyways, I just wanted to share that. I thought those of you who followed my ray tracing experiments over the years, don't know how many of you there are, but yeah, I thought you might be interested. That's the conclusion. In conclusion, it's a cool idea. Doesn't work as well as I'd like it to in practice. In the meantime, I'd stay with rasterizers for 3D games design, personally. That's my conclusion. Path tracers are really cool, though. I still love doing them for offline stuff. For offline rendering path tracers, oh gosh, they're so much fun. But anyways, that's a whole other can of worms. Anyways, I have a lot of other things I could ramble about, but I think I've done just about enough rambling for the time being. So, thank you very much for joining me. I hope you enjoyed, I hope you learned, and I will see you with any luck in the very near future. So, yeah, thank you. Until next time.